Welcome everyone to the webcast on ingestion coordination through metadata. So today we're going to go through a bit of an introduction at the beginning, get into talking about ingestion flows and metadata orchestration, followed by a short demo to showcase what we were discussing, and then we'll end with some next steps. So first, I'd like to start with a short introduction of ourselves and then Thorogood as a whole. I'm John Miller. I'm joined by my colleague, Utkarsh Panchal. We're both data and analytics consultants at Thorogood, and we're based out of our Philadelphia office. We have a lot of experience across a wide range of projects and clients, so we do encourage you to reach out via email or LinkedIn. Both are shared here. So for those who don't know, Thorogood is an independent global professional services firm specializing in data engineering, data science, and data visualization strategies, solutions, and services with a focus on our customers. We are a global company with offices in Boston, Philadelphia, London, Bangalore, Singapore, and Sao Paulo. We're really covering almost all of the time zones there on the globe. All of our consultants are recruited and trained in the same way to help develop a unique mix of skills, blending business understanding with strong technical aptitude and then a deep understanding of analytical tools. We offer a full range of services, including strategy and roadmaps, requirements, design implementation, and training and support. Thorogood is independent, so I mentioned that at the beginning. So that means that we do not work only with one specific technology. However, we maintain close partnerships with many of the key vendors in our space. Shown on the screen are just a few of the major technologies that we work with. We find this independence is helpful to have a more holistic view of the space, understanding our customers' needs regardless of what their current data landscape is, and then trying to identify the best possible solutions for our customers based upon those needs. I'm now going to hand it over to Utkarsh to talk to you about ingestion flows.
So our topic today is on ingestion coordination through metadata. The main goal of that is ingestion, and more specifically ingestion flows, or how you're moving data from a source system and turning it into something usable and accessible to your business. Ingestion flows can vary in complexity but follow the same basic goal. Identify your source data and apply appropriate transformations so that it can be used by the business. Starting with your source data, it's common to have data from various places and in various formats. The number of sources and variety of sources can introduce more complexity as you try to bring data together. This source data gets ingested into your data lake. I've separated the data lake into 3 layers, bronze, silver, and gold, which follow Databricks best practices. As data gets ingested into the bronze layer, it is then cleaned, transformed, and conformed into your final schema in the gold layer. This is accomplished by calling Databricks notebooks to read from one layer, conduct transformations, and write to the next layer, typically using Delta format, which has some advantages when working within a data lake. It's not mandatory to set up your process in this fashion, but it's important to understand the best practices to then be able to modify it for your needs. After data is in the gold layer, it is then ready for consumption by downstream processes. That could be data science applications, updating a database/warehouse, or data visualization in a tool like Power BI, Tableau, Looker, or QuickSight. Databricks is a helpful tool for executing the transformations as it is easily integrated in any cloud provider stack of tools like Microsoft Azure, Google Cloud, and AWS. One thing missing from this diagram is an orchestration tool like Azure Data Factory, which would coordinate the extraction of source data and execution of Databricks notebooks through pipelines. We will talk about said pipelines now. In practice, the challenge with ingesting multiple different sources through the same ingestion flow is that each source may require separate Databricks notebooks since they contain different data and are different file types, and this can translate into a large number of pipelines to create and manage. The sample ADF pipeline here shows a very simple pipeline, just one step that calls a Databricks notebook to run the needed transformations to write from one location in the data lake to another. But what happens with another source, or another source, or another source, each requiring their own Databricks notebooks? You can imagine that a few issues come up when using this approach. A notebook is typically only for one step in the ingestion flow, moving from bronze to silver, for example. What happens when moving from silver to gold? Does that add a follow-on step to each of these pipelines? How do you automate this process so that a user doesn't have to know which pipeline should be run and at which time? This approach is not very flexible to handle different frequency of files being provided. How much duplication of effort will there be to add more sources or add more complexity to the pipelines? Will it be messy to manage and maintain? Creating these individual pipelines with duplicated tasks, while in the short term may seem like the easiest approach, can greatly increase the long-term management and update efforts. If you're looking to automate and productionize your recurring ETL or ELT processes, this is where metadata can come in. Metadata orchestration alleviates some of the concerns with source-specific pipelines and a hard-coded task by introducing parameterization. But first, to make sure we are aligned on an understanding of a term that will be referenced frequently, I think it is best to start with a definition. Metadata is a set of data that describes and gives information about other data. A crucial omission from that definition is that metadata does not provide the content of the data that it's describing. There are a lot of metadata that you will likely interact with, but a few examples that are helpful in orchestration of ingestion loads are data types, so strings, integers, and dates, file names, and file formats such as Excel, CSV, Parquet being some of the common ones. So how do we take this data that describes our data and use it to help orchestrate loads? We can capture it in a single table and save it in a location that can be referenced later, passing in the values like parameters to be used in pipelines and even in Databricks notebooks. So how is a typical metadata file set up? All metadata files should have a unique way to identify the source file that you are trying to ingest, which is why we typically start ours with the metadata ID column. You can reference the metadata ID column during pipeline tasks and Databricks notebooks to indicate which data source you want to be loaded. Next, you'll want to identify each source file and include the extension so you know how it should be ingested with a data source name and a data source extension column. The name allows others to easily identify the source when troubleshooting, and the extension can be used to ingest data. It's common for data to become in different formats, so it's an important consideration designed for flexibility of file type. Depending on your pipeline, you might have to have one Databricks notebooks or multiple that you'll call to transform each source. The Databricks notebook path column allows the pipeline to identify and locate these notebooks. The number of columns that you include in your metadata file will vary based on your use case. For example, you could add the following to further parameterize your pipeline and Databricks notebooks: naming conventions and file types, frequency of loads to separate data that is loaded into daily, weekly, and monthly tables, and read and write paths for delta tables. In this very simple example, we can see that although we receive sales data from two companies in CSV format, we want to use two separate notebooks to process the data. This is because, like we often see, Company A and Company B don't provide their data with the same columns, requiring transformations to bring both datasets together. This file then can be stored in a location as referenced by our pipeline in notebooks such as ADLS. With the addition of a metadata file, our pipeline can go from individual pipelines calling a specific notebook, as we had before, to a generic pipeline that can be used for each source. Now, there are a few differences between the pipelines. First, that there are more tasks now instead of one notebook task. We now start with a lookup task to get the information from the metadata file. Since we have multiple lines in our metadata file, the lookup returns both of them. Now we use this metadata to control which notebook gets executed. We want to filter our lookups to the specific metadata ID and then pass the Databricks notebook path in our notebook task by calling the output of the filter activity. Now I'll hand it over to John to walk through a short demo.
I'm hopefully going to bring to life in this demo a little bit about what Utkarsh has been discussing. We're going to take on the role of a business that collects sales data from two different companies. Our analysts want to view this data in a single object. We know that the data gets sent every 5 weeks and that we don't have to consider restatements. And our goal is to build an ADF pipeline that can call specific Databricks notebooks that will transform each file and write it into a single Delta table that can then be queried by analysts. So with that, let's jump on in. First, I'm going to show just what the source data is going to look like. So we can see here, pretty simple file, time, the product code, unit sales, and dollar sales. So pretty easy to be able to read that in. But if we then bring in our second file, so this is from Company B, we can see that Company B uses a slightly different format. And That's not all too uncommon from receiving data from different retailers. If you're tracking sales data or different data vendors, they often all have their own format for what they think is best. Sometimes they'll edit it into a specific format for you. Sometimes you have to do that work yourself. In this case, we had to do this work ourselves. We can see that there's an additional column for company B, different naming for their time column, different naming for their product column, and then unit sales, dollar sales, and an addition of a country. So here's our data. Where we keep this is in a ADLS storage account. So in source path here, we keep these files available, those CSV types. Looking in the notebooks, we do have 2 different notebooks that are going to be used to process that. The reason we have 2, there's different transformations that are needed. And while you could jam everything into a single notebook, it's a bit easier to manage and maintain by having separate specific notebooks for each source. So ignoring a bit at the top there, is that'll come in with the metadata a bit later. The general purpose is that we're going to read in the source data here. We're going to do the transformations to it that we need. So we can see in the case of company A, we need to add in some additional columns. We also want to rename a number of columns to get to this final schema. And then we're going to write it out to a delta table location. Same thing for company B. Again, load the source, some slightly different transformations, but we're going to write this out to the same path there to be able to bring that data together. We're using the mode append here because, as I mentioned, we don't have to worry about restated data, so we don't have to worry about trying to overwrite. Oftentimes, people do have to consider restatements, so you'd be using an overwrite and then a replace where to let Databricks know where do you want to be overwriting this data, what do you want to consider in that approach. So this is all well and good. We have 2 notebooks, it'll process it, get it into the location we want. But right now, this would just be manually run by someone to go in. It's not very foolproof long-term, requires a lot of manual intervention, and it doesn't include what the topic of this conversation is, which is around metadata. So if we can start with our metadata file, which looks similar to the one that Utkarsh had shared, metadata ID, say what the source name is, extension, have some information around the file type, so what source separator is used, does it have headers or not. And these additional columns are all just so we can make the notebooks that we're running as parameterized as possible. And then the key point in this demo is having this Databricks notebook path. So this will get passed in later to let Databricks know which notebook should be run. This file gets stored also in our ADLS location. We have a metadata file here, and that allows it to read in later and bring in the information that's required. So if we look in our Databricks notebook, we can see that we're reading in the metadata file. We're going to filter it based on the metadata ID. So we only get the specific row that corresponds to the file that we want. And then when we're reading in the data from the source, we're using these variables that are picked up from the metadata file and assigned a bit earlier here. So that corresponds just to the values that we have here of a comma and true, which are just settings that are needed to read in that CSV file. Again, how does this really come together? Well, it really comes together when you have your pipeline. So in the pipeline that you have, this is what Utkarsh had shared. We have 3 steps. Start with a lookup. Lookup step, pretty generic, just is going to read from the data set that we've created. Our data set just points to the metadata orchestration file that I just shared. This returns something that looks like this. So it pulls both rows into JSON format like this. And you can see all the different variables that get assigned based on metadata ID. Then we want to filter in the next step. We want to filter it to the file that's being loaded. How do we know which file is being loaded? We've added a parameter to this pipeline. This pipeline, when you run it, it's going to ask you which metadata ID do you want to run. So which file do you want? File 1 or do you want to run file 2? Using that information, we're able to filter down the output of the lookup into something that is more specific to the file that's being loaded. So we can see here that I've ran this for metadata ID 1. So that list of 2 items now drops to 1. And we can see all of the different variables in here with the metadata ID of 1. The reason this is important is because in our next step, we only have one Databricks step. So we can't hard code in both notebooks. We have to use some more dynamic content here that takes the output value of the metadata ID and then assigns the Databricks notebook path based on whatever that outcome is. So if we look back at this, we're taking essentially this Databricks notebook path. That's the path that we want to run, and that's what we'll run and write the files out. So this is really nice because it allows a lot more flexibility how you manage your data. This is a relatively simple example here, but as you can imagine, there's a lot more complexity that can be added to it and more parameters that you can pass. And if you have a lot more steps in your process, there's more Databricks notebooks that will be called, more filtering, more variables to get assigned. And then even within your Databricks notebooks, you can be passing in these variables to help try and parameterize them. Are there ways to have a common notebook that can support multiple different file loads? Those types of things are things to think about as you're loading this data. So hopefully that demo has helped to solidify some of the points in the presentation around why coordinating your ingestion process with metadata is a good decision. I've summarized some of these few key points here as well. First up, it helps keep you organized. In my opinion, it's a lot easier to manage one metadata file than be worrying about multiple different pipelines, multiple different notebooks, making sure everything is organized and being called at the right time. If all your settings are essentially in that metadata file, it's one place to go. You can update that. With that being all in one place, it allows you to enable, or it enables you to use some more common architecture. So a single pipeline instead of multiple different pipelines makes it a bit more maintainable and reduces redundancy and having to update multiple different pipelines with the same tasks. It's a bit more flexible in that metadata file. It's easy to configure it, and it's ready to grow with your evolving needs. So if there's more things that you want to be able to pass in for each specific source, it's easy to do that with that file. And it's also accessible because it can be referenced throughout your pipeline. And even within your Databricks notebooks, you can pass those variables directly through to allow it to write to certain locations, have certain names for the tables that you're creating. So with that, thank you again for tuning in today. If you can take a moment to share any feedback you have by scanning the QR code shown here, it would be greatly appreciated. The survey will also give you an opportunity to share some information about topics you're interested in, like I mentioned. And if you'd like to set up a time to chat with Thorogood about different initiatives you're on, there's a box in there to indicate that you're interested in doing that. As I said, you can also feel free to reach out to us with any questions. Our emails are listed here as well as our website. So thank you and have a great rest of your day.